Okay, in this presentation we are going to look at Poisson random variables. And in this instance what we're going to look at is the confidence interval for the difference in means or the difference in rates between two groups. Now historically, but not anymore, historically they might be categorized by male or female drivers. So essentially we work on that basis there, what might have been done historically in Europe anyway. It is assumed that the number of claims arising in 1 year from motor insurance policies for young male drivers, that's the first group, and young female drivers, the second group, are distributed as Poisson random variables with parameters lambda m and lambda f respectively. Okay, so independent random samples of 150 policies for male drivers, so that's 120. Okay, that's a large sample, so that's the first group, N M for male, and 80 for female policies, so NF for female. Individually, they're both fairly large samples. That's important later on. Okay, are examined and yielded the following mean claims per policy. XM, probably should put a bar there, equals 0.24 and 0.15 respectively. So 0.24 claims on average for males and 0.15 claims for females. Okay. So essentially what we want to do is calculate a 95% confidence interval. Now, calculate an approximate confidence interval. Now, in other videos, I might have made more of a song and dance or put more emphasis on explaining how the approximation is justified, and it's based on the sample sizes there. I'm going to sort of skip that in this video just to sort of speed things up because I've got other things to emphasize upon. So also just actually remark it's a 95% confidence interval, so that means the quantile is going to be 1.96. If you're not sure where that comes from, I think you're going to jumping too far ahead. So that's a sort of fairly common in the confidence intervals for large samples. And so essentially this is the difference we're looking for. This is the difference in means, the difference in mean rates, and the difference in between respective Poisson parameters. Okay, now this is going back to the introductory stuff about confidence intervals and hypothesis tests. Okay, so the standard error for means is the variance of one group, sigma 1 squared divided by the sample size of that group, plus sigma 2 squared divided by the sample size of that group. Okay, so essentially what we're going to do here is approximate that. Okay, and just actually as a remark, for both groups, the mean, well actually let's just sort of in clearer terms, the expected value for x, lambda actually is the expected value of x, but it's also the variance of x. Okay, so our variance estimates for males and females are also 0.24 and 0.15. Okay, so that's our variances there as well. Okay, so our essentially I just put in, or otherwise put in the same numbers there. That's our variance estimates. Actually, what I could do is actually also call that lambda hat, our variance estimate there, our estimate for lambda. Okay. Now, so this is our point estimate there. We have our quantile, which is 1.96, and then our standard error. Okay. So this is a typical structure of a confidence interval. And again, just to emphasize here, x bar and for M and F is the point estimate for the mean, but also that actually functionally is the variance estimates as well. Okay. Now, so essentially that's everything we have there. Sorry, this the 120 is the sample size for males, and 80 is the sample size for females. Okay. So essentially we have everything we need there now. So essentially what is now just a bit of calculator work. The difference there is 0.24 minus 0.15. Okay, that's 0.09. Plus or minus 1.96. That's sorted out there. And this here, this term here, this is just a little bit of calculator work. 0.24 divided by 120 plus 0 plus 15 divided by 80. Yeah, just have to work it out. It's just a little bit of calculator work. Just spend a bit of time in it. You should get an answer close to 0.062. And then when we work it all out, this is the difference in rates. So it is minus 0.032 to 0.212. Okay. Now, essentially, what we're looking at here, I'm not going to really interpret it here, but it sort of says that there's not enough evidence to suggest that males and females have different different rate parameters at a population level. Okay, if you were asked to interpret it, okay, using 95% confidence interval. Okay. So, not really an interpretation there, but it sort of says not enough evidence of a difference, even though it's sort of at 95% confidence or 5% significance if you prefer. Not really asked in the question there, but that's the answer we're looking for there. Just remember to sort of spell it out. This is a 95% confidence interval for the difference in means between males and females. Just a sentence at the end just to explain what your answer is. All right, we'll leave it there. Actually, so just actually the key thing really from this exercise really is just knowing how this becomes this, okay? And it's all to do with the lambda being the variance and the expected value. So that's why we have lambda in there, okay, or x bar if in this case. Okay, we'll leave it there.